Okay, so there's two things today that are both similar to things we've done this year, but we've not exactly done either of these things. So first thing we want to figure out is how to do the area of triangles, which we've done areas, but not with triangles this year. And then we're going to compare some numbers in a second. Let's start with area. First, anybody remind us someone of what area is about?
The whole outside of the shape.
That's close. We got that confused with another word.
Like the inside.
It's the inside space. What's the around it, the outside of it? What's that word from another? Another, it's a P word.
Perimeter.
Perimeter. Okay, so perimeter goes around. Area is the space inside. So today we're going to do areas of triangles, space inside of triangles. Add, subtract, multiply, divide. What have we usually done to figure out areas? We've done areas of rectangles, we've done areas of parallelograms, we did areas of squares. Any memories of area, what you usually do when you're doing areas? Add, subtract, multiply, divide.
Add.
No. So subtract, multiply, or divide? Multiply. Usually how many numbers do we multiply? 2. Okay, so for rectangles, if I drew you a rectangle and said this is 2 and this is 10, what's the area of that rectangle? 20. Area basically amounts to counting how many squares are in a shape. And I don't have the patience to draw 10 lines like this, but it would be stacks 2 high, 10 wide. There'd be 20 squares in there. Area counts the space inside. Does anybody for triangles remember anything that's special about doing areas of triangles? Because this is a little different than anything that we've had. Any memories from your prior maths of triangles, doing areas, something that's up with that?
There's usually a dotted line that goes.
There's usually a dotted line, that's correct. Okay, so now I'm going to go ahead and draw myself in a dotted line, and I'll put a number on that. I'll say 3. So if I improve the picture now we can do the area. A minute ago, we couldn't even do the area of that triangle. Okay, but if I draw in this dotted line, now we're good. Now we can do the area. Anybody else have memories of doing it? Yeah.
Would the answer be 24?
Answer involves 24, but it's not 24. Let's start with how did he get to 24? Where did 24 come from?
He had multiplied 3 times 8.
We go 3 times 8. If there is one of these dotted lines, we could call that the height. We are going to multiply that by a thing called the base. Okay, the 3 and the 8 are the height and the base. What relationship is there here between those two sides, how it's making like that T? It's a word we used by accident already today once, but now we want to use the word. What relationship is this? Perpendicular. The height has to be perpendicular to a base. So 3 times 8 is 24. We did that with parallelograms. Okay, before our break, I would draw you something like 10, 5, draw in a dotted line and make that a 4. Who would we have multiplied to do the area of that parallelogram from before break? 2 times 2.
4 times 10.
4 times 10. We always use the dotted thing, the height, and always we multiplied by whatever it was perpendicular to. We're still doing that today. 3 times 8 is still a thing. We're still thinking 24, but the answer's not 24. There's one more important detail that sets today apart. This is only for triangles, does this. Does anybody remember?
You add 6 to it?
You don't. You cut it in half. We're going to do the base times the height like we were for parallelograms, but we're going to cut it in half. So we're going to go 3 times 8 is 24. That makes the final answer be 12. Here's why. This triangle is actually half of the parallelogram. If I grew this shape up into being a parallelogram, and I take this away, what would we do the area of this parallelogram? Who times who?
8,
8 times
8,
8 times who? 3. For parallelograms, we always use the dotted line times who it's perpendicular to. 3 times 8 is 24. If I go like this, I just cut that parallelogram in half. Okay, these two triangles are the same shape and size. You're always, for triangles, going to have to cut the thing in half. We're going to multiply two numbers, we're going to cut the thing in half. I could have drawn this different ways. I could have drawn my dotted thing this way if I wanted to, because this and this still have what relationship was this called? A word we've already used twice now today. Perpendicular. Those are perpendicular. If I told you that was a 4, we'd multiply 2 times 2.
8 times 4. No, 6 times 4.
6 times 4. 6 times 4 is
24.
24, but the answer is still
12.
12, because I've still got to cut that thing in half. Question about that? I'm somewhat unconvinced. We seem a little bit not super quick on that, so let me go another round of that. So let me go 5, 6, 7. I've got to draw you in one more thing. Some kind of a dotted line. I could go straight up and down to touch the 7. I could go through here to touch the 6. I could go through there to touch the 5. It doesn't really matter. Make a choice. Which way do you want me to go? You want me to hit the 5, the 6, or the 7?
7.
I'll hit the 7. Okay, so if I come straight down to be perpendicular to the 7, then I've got to just give this a number. Let me say 4. So who times who now? 7 times 4 makes 28, but the answer's not 28. The answer's 14. Question about that?
Will the first answer can always be like even, and then when you cut it in half?
That's a very good question. Would the first answer always have to be even?
Yes. No.
No. So most of the homework, it will be. They'll take it easy on you. Okay, but if I went like 5, 6, 7, drop that in, and I picked a 3, now we've got to multiply who times who?
7 times 3.
7 times 3 is
21.
21. Half of 21 is less fun. What is half of 21?
11. 10 and a half.
10 and a half. We could go 2 into 21 is going to go 10 to get us 20. There's a remainder of 1. You could either go 10 and go fraction with a half, or if you want to add a decimal and keep dividing, you could go 10.5. That can't happen. Question so far on that? This triangle, I do not have to draw you a dotted thing. Does anybody have an observation on this one, why I don't have to draw you a dotted thing? Go to you.
3 and 4.
3 and 4 are already perpendicular. So we can just multiply 3 times 4. So the answer is 12? No. Answer 6. Why is the answer 6, not 12? Why did I cut it in half? I tricked you on purpose just to remind us we've got to go half all the time, all the time. Now, could I draw in a dotted thing to touch the 5? I could, but why bother? If we've already got the 3 and the 4 that are perpendicular, just roll with it. Again, the reason we're cutting in half, what is this triangle half of? What shape? It's not a square, but what's that shape?
Rectangle.
Rectangle. That's a rectangle. So if I wanted to take this away and just do the area of the whole rectangle, it would be 3 times 4 is the area of the rectangle. But every triangle is like half of a bigger thing. So we're always going to look to cut the triangles in half. There's no other shape we'll do areas for this year that will cut anything in half. It's just going to be for triangles. Okay, area is always going to be a multiply. Triangle is going to be our only one we cut in half.
I just want to say that's a square. You said
Maybe an illusion there.
It looks like a square.
Because if this is 3 and this is 4, those aren't the same. So I didn't draw that to scale is what that's called. Like, I'm not, if this is 6, is this truly 8? Probably not, but I'm not going to get a ruler out and measure my shapes as I
So,
draw
like-
them. If this is 6 and this is 8 and I wanted it drawn to scale, I should have probably drawn my 8 a little bit longer than I did, but
So like the top
if
right
that's
corner.
3, that's longer. That's longer than that. So if I use my hand as a measuring tool, if that's 3, that's more than 3. That's pretty close to 3 by 4. That's not bad. It's maybe 3 by 3.8, but it isn't exactly a square, because those aren't exactly the same, but it's close. It's wider than it is tall, I think. Question about triangle stuff? The second thing we're going to do is compare. We've compared before. Anytime I say compare, what are we hunting for? What's our options? Greater than, less than, or equal to. Which one is this?
Great.
That's greater than. What we've never done until today is compare where negatives got involved. So if we go to compare -2 versus -3, who's the bigger number? -2 is the bigger number. So I'm using that symbol, which is which one?
Great.
Greater than. Can anybody explain what the rules are for this, or have a way to make this make sense to other
Is it
people?
like the closer number to 0?
If they're both negative, it would be the closer number to 0. Yes, that's true. Anybody else have another observation we could use?
The smaller negative, like the smallest negative.
Yeah, if you're in negative land, it's reversed. Just like in English, when you use a negative in your sentence, what's it do?
Positive.
It reverses your sentence. So what's an example of an English word you use that it's a negative word in sentence creation? You want to create a negative sentence, what word do you use?
Stupid.
No,
Or,
not. Not is a word that creates negatives. So you say, I did my homework. I did not do my homework. That's a negative. We've made the sentence opposite. So if we make both of these numbers opposites, it's the opposite size. -2 is a bigger number than -3 because 3 usually beats 2. Negatives are opposite. That's a confusing way to explain it though. Anybody have another thought on what's up with this? Okay, let's think number line. Where can you always find bigger numbers on the number line? To the right. So whoever's farther right on the number line wins. So if we go looking for -2 and -3, -2 is on the right. That's an automatic winner. That's a way you could do it. Another way you could do it would be think of like a real life situation where you might encounter a negative. What's a real life situation you might encounter -2 or -3?
money.
How do you have -2 money?
Debt.
Yeah, debt. That's fine. Yep, I wasn't sure where you were going with that, but I'm with you. Would you rather owe your friend $2 or would you rather owe your friend $3? You'd rather owe your friend $2. You're not real happy either way, but if you have to pick one, that's the winner. Where else in life might you encounter negatives?
Banking. Or no,
Other negatives?
temperature.
Temperature. So we had a few days like this recently. You're not real happy about it being -2. You're not real happy about it being -3 either. But if you had to pick one,
Negative.
you'd pick the -2. Football. This is like your team just lost
2 games.
2 games or 2 yards. Here your team just lost 3 yards. You're not real happy, you're yelling at the TV either way, but if you had to pick one, you'd rather lose the 2 yards. Okay, so comparing, if they're both negatives, it's the opposite of what you're used to seeing. So who wins between -5 versus -4? -4. Neither one's great, but -4 is more to the right on the number line, it's just less damage being done. -3 versus -2.7. Good, winner would be?
-2.7.
-2.7. We're only worried about the first digit when we compare when decimals start to play. Unless they both have decimals. Then you have to compare numbers in the same place. Negative 0.2 versus negative 0.3, the better number?
Negative 1, 2.
Negative 0.2. If I go like this, all of a sudden it's not even a thought or a contest. Why is this not even a thing we've got to really even think about anymore?
Because it's negative and one's not.
Yeah, so who's going to win every time?
The 3.
The 3. Any positive number has to beat any negative number. The only time you've got to pause and think and make sure you've got the right thing in reverse of normal is if negative competes with negative, the littler value is actually bigger. But if positive competes with negative, it's game over. Who else would be game over competing with negatives? Who's in a category of his own?
0.
0. 0 versus negative, automatic winner is every time
0.
going to be the 0. Okay, so negatives always lose the 0 or positives. There will be some comparing where they do that. They might even throw you a question like 1 minus 3 competing with 3 minus 1. Who's going to be the winner of that? Thing on the left or thing on the right?
Right.
Why the thing on the right?
Because that one's going to be 2 and the other one's going to be negative.
Yeah, that's going to be positive. So bigger minus smaller is going to always be positive. That would always beat the reverse subtraction order. Positives always beat negatives. Question about areas of triangles or comparisons. People will always forget the key thing about area, so I'll say it again. For triangle areas, what's the key thing that's unique to triangles and only to triangles?
Oh, the dotted line.
Yeah, that we did dotted line on other shapes.
When you multiply it, there has to be 2.
That's been true of other shapes as well.
2 is
You have to cut it in half. Triangles, we have to cut the area in half. We're going to multiply our two perpendicular numbers, but you have to cut the thing in half. Where we're headed, homework today, there's a 205. We're just going to do some letters on 205. The 205 letters are 3 triangles. So 205 ABC. The main place we'll set up shop is on 207. 207, we're just going to do all of it. There's some letters that do some comparisons. And then there's a 1 to 25 that's a little bit at everything we've ever seen together. You hit the stop on that.